Oh, now it finally works. Good morning, everyone. I'm using a different mic setup now. If anyone wants to confirm in the chat that they can hear me, that would be excellent. I was using this for my second class on Tuesday as well, but I don't think I was using it for y'all. But I'd still like to get a confirmation that I'm clear enough and that I don't have to put my headset back on. I've got basically 4 hours of teaching back to back, and the headset was giving me a headache every time, so I'm trying just to use the default one on this. I don't see anybody saying anything. Does that mean you can't hear me at all, or? Let's see. Okay, cool. All right, and on top of the fun, my computer crashed about 5 minutes before class started, and I had to reboot it, so everything's just loading, and my math app was being slow, blah, blah, blah. So I'm just taking an extra 10 seconds at the top to figure us out, get where we want to be. Okay. This isn't even us, so we can close that. All right, so your reminders, 1.2 and 1.3 from your My Math App homework are due today by midnight. Remember, all due dates are always midnight. We did 2.1 last class, so that's due on the 9th. We should be knocking out 2.2 and hopefully 2.3 today, so that'll be due on the 11th. If we don't finish 2.3, then its homework would be due the class after the 11th, which is what, the 16th? Then the next reading, again, assuming we do finish 2.2 and 2.3, you'll read 2.4 and at least, touch your eyes on 3.1. And when I say read, I mean the ebook in My Math Lab, which again is when you go to e-text contents, then the chapter in the section, as well as the chapter notes that I have in Canvas, which are very, very, very brief in comparison to the textbook. I mean, this was the chapter 2 notes, but I now have some extra writing in it. There's the rest of the chapter 2 notes, which is not that much, as you can see. Okay. Excel, the 1.3 heart rate was already due. A couple of you were emailing me, and I answered some questions about that. A couple of you emailed me and then said disregard. So if you still had any questions about it, let me know. But if I see a disregard, I do as you say, disregard. The discussion boards keep coming up and keep coming up. There's something I need to say about that. I can't remember. I'll get to it later. And then your next two Excel homeworks. Actually, I said 1.3 was the heart rate. The car loans. Why does that number sound wrong? Either way, the one that says car loan is next, and that's due on the 9th, which is next Tuesday. And then 1.8, your BMI, that's due the Tuesday after. So we're pretty much pumping out one Excel for a week, or one Excel a week for a while. There will be a break in this at some point as we get closer to discussing the project. So this project, you may have seen that like in your grade book in Canvas, saying, well, what is the project? I've said that it's probably going to be a budget thing, but I haven't given you the exact details. I do change my projects every semester, if not completely, at least with subtle details. So we'll get to that when we get to like chapter 3, chapter 4, a little further down the line, kind of like when we're preparing for a midterm. But for now, let's get back into chapter 2. I minimized too much. There we go. I can mouse, I swear. And let's just do this. 2.2, the weighted average. So in this class, your grade is determined by a weighted average formula. So before we get into what this thing is, this actual weighted average, let's talk about the old school. I'm spelling it funny to be silly. The old school average. What do you do to get an average, just a normal old average? Well, you add up all data, then divide by the number of data. So add up all the things and then divide by the number of things. So let's say that your class only had 10 grades and they were all worth the same. So they were all homework, so they were all quizzes or whatever, and you just wanted to find the average for that little section, or maybe you just the whole class works that way. So you just take grade 1 plus grade 2 plus grade 3 plus yada, 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 then add grade 10. After you get that sum, then you divide by 10 because there were 10 grades. Now, this can be used to get your Excel averages, your MyMathLab averages, and your quiz average. So remember, in this course, your Excel homeworks are 15% of your grade. Your MyMathLab homeworks are 15% of your grade. Your quiz homeworks are 15% of your grade. Those are independent categories. So inside of a category, you can just add up all of the grades and divide by the number of grades. So if you've turned in 3 MyMathLab homeworks, and that's all that's been due so far, then you could add those 3 grades, divide by 3, and that would give you your MyMathLab average. Now, every year, every semester, every month, I've got students asking me, hey, is my grade in MyMathLab correct? No, it's not. Your grade in MyMathLab is always wrong. It's always wrong because, and I've mentioned some of this before, it doesn't account for zeros. If you skip an assignment, you've got a 0 in my grade book, but MyMathLab just leaves it as like a dash, and it doesn't get included in your average, and I can't fix that, unfortunately. So don't trust MyMathLab for your MyMathLab homework grade. Also, MyMathLab might not contain every single one of your Excel grades. There was one that was turned in through Canvas, which I still need to actually go through and grade. I've been so busy kind of preparing for my classes this semester in their very, very wildly different format on top of something else, prepping for the fall, that I still need to go back and do those grades. I will get that done tomorrow. It's kind of been on the back burner. So there's chapter 0 grades. I'll go through and get them done. Quizzes also. Some of your quizzes will be directly in Canvas. Some of them you have to submit that piece of paper, that document, and then I go through and grade it, and it calls it an assignment instead of a quiz. And it's, again, something I can't control. I can't make a quiz with a document upload. At least I haven't figured out how to, if there's an option, and I've tried. I've definitely tried. So your little quiz grades in individual places are not necessarily going to be right. What you want to do is you want to collect everything on your own. On top of that, remember I said I'll give you up to 10 points on every MyMathLab assignment, as long as it doesn't go over 100. So if MyMathLab says you have a 91, in reality you've got 100. So what you could do is make up your own little Excel file. And this was a project one semester. I could still do this as a project. And you could say, all right, that was weird. So here we have my MyMathLab homeworks. So maybe on the first one, I got a 91, which means it's 100. Maybe on the second one, I got an 89, which makes it a 99. Maybe on the third one, I got a 72, which makes it an 82. Maybe on the fourth one, I got a 99, which makes it 100. Maybe on the next one, I got 100. And you could even have labels next to these if you wanted. I can move these over. I could say, here's homework 1.1, 1.2, 1.3, 2.1, 2.2, something like that. And then way down here, so that you leave a space for every single assignment that's coming up, not just the ones you've done, because we're going to have, like 30 homeworks. So maybe down here, you just write average. And then you could use Excel's built-in average ability, which just adds them up and divides by the number. You don't have to write all that stuff. You just write equals to make Excel know it's going to calculate for you. Average, open a parentheses. And then you just want to average all the different homeworks. Now, Mr. Beckner, there's all these blanks here. What's going on? You only have 5 homeworks. Or 6 homeworks, or how many of that is 5? Why are you including all these spaces? That way I don't have to go through and edit this average function later. So when I do this, Excel is not going to count all these blank spots because there's nothing written in them. Now, if I write a 0 here, watch what happens. My average goes down. If I put another 0 in, watch what happens. My average goes down. But without those zeros there, because those assignments really haven't happened yet, looks like I've got a 96. I'm doing pretty good. but now all of a sudden I miss homework 2.3, I don't turn it in. Well, that's a 0. Then I miss 2.4, I don't turn it in. And then I get back to being on top of things and I get 100. And you can see that average keeps updating every single time I put in grades, whether they're bad or whether they're awesome. And then you could do the same thing for your quizzes. So you could have a column for your quizzes, and you might want to leave some space for different labels and everything. It's up to you. So quizzes. So I forgot to turn in the first quiz. So I get a 0 on that. Then my second quiz, I made sure I did it and I got 100 on it. My third quiz, I got a 95. And then you're not going to have nearly as many quizzes, but you could put all the averages on the same spots. And you go equals average, open parentheses. Highlight all the cells you think you would need. So, you know, there's not going to be any more than 15 quizzes in here. So I'll highlight rows 2 through 16. Close my parentheses, hit enter, and right now my average is 65. Oh, I need to bring that up, so I make sure I do well in the next quiz. I get a 95. Average goes up. Then you can do the same thing for your Excel homework. I am telling you all to do this. This is not an official assignment, ... yet. I can choose to make it an assignment. I can choose to make this the project if I want to. And then somewhere you can put the cell for your weighted average, which involves this formula, which we haven't even used. So again, so far all we talked about is this old school average, which is adding up things and dividing by the number of things. And using the word average is, I don't want to say it's a misnomer or that it's wrong, but it's kind of a weak term. Because what I've just described, this old school average, is technically called mean. Adding up the data and dividing by the number of data officially is called a mean, but we use it so often that most people just call it an average. But there are two other types of averages, and those are the median, which is just the middle entry, and the mode, which is the entry that occurs the most. Now, this is not a statistics class, so we're not going to do a lot of statistics. We might talk about mean, media, and mean, medium, and mode. Maybe one or two more times, but we're not going to get into any kind of crazy statistics. We really don't use those last two that often. So the weighted average, and this is the formula, and this is a formula you're supposed to memorize. This is a formula you are supposed to memorize. This will never be on a formula sheet for us. It's very similar to the old school average. That's why it's called a weighted average. The weights make some things count more than others. So if a homework assignment is worth 20%, but a quiz is worth 10%, and that's not how this course works, I'm just kind of describing a scenario. If a homework's worth 10% and a quiz is worth 20%, I may have said that backwards, but let's go with this one. If a homework's worth 10 and a quiz is worth 20, that means that a quiz is worth twice as much as a homework. So it's weighted as 2 homeworks, essentially, if you wanted to break things down to the smallest scale possible. And that's easy because it's 10 and 20%, but in classes where some things are worth 50% and some things are worth 7% and some things are worth 15% and some are worth 2.5%, you can't necessarily break it down to the, okay, this thing counts as 1, this thing counts as 2, this thing counts as 7. So you have this weighted average formula to use that. So it's really just adding up a bunch of things. This is adding one thing plus another thing plus another thing. That's what the ... means, plus another thing plus another thing. And then dividing by, instead of just the number of data, it's the sum of the weights. So a number of data, if there's 5 elements, you'd be dividing by 5. If all of these things were weighted the same, they'd all have a weight of 1, and you'd be dividing by 5 because you'd be adding 1 plus 1 plus 1 plus 1. But the things in the top that you're adding are a product. The weight times the data plus the weight times the data plus the weight times the data plus the weight times the data. So the top is just a bunch of sums adding a bunch of weights times datas. They're paired appropriately. So if your quizzes are worth 15%, then you take the quiz grade and you multiply it by 15%. If the project's worth 5%, then you take the project grade and you multiply it by 5%. And you can do these as decimals or percentages. It doesn't technically matter. And I'll actually show you both ways with one of them to show you that it works. It's all about consistency. So the top is just adding up a bunch of weights times their datas. The bottom is just adding each weight. Sometimes the bottom is 100, sometimes it isn't. And by 100, that's if you're using percentages, or 1 if you're using decimals. When we're talking about doing a weighted average for a course, which is how we tend to relate things in here, because it's the most relevant, because you can take this and use it for all your other classes to find out your grade without having to ask your teacher, well, Mr. Beckner, what's my grade? This is a class where I teach you how to fish. I don't just give you a fish, I teach you how to fish. So if anyone ever asks their grade, I'm going to say, hey, go back to 2.2 where we gave you the weighted average formula. Go back to your syllabus where we gave you the weights for this course and do the math, because that's what quantitative reasoning involves. Learning and growing and understanding how to do it yourself. And I've also demonstrated very quickly, and you can pause and rewind on YouTube, how to just quickly get your true averages for each category. So as you get grades, go back and update your own personal grade book. I could go and save this. Rodney Beckner's personal grade book. Rodney Beckner needs to do better on quizzes, and he needs to remember to do his homework sometimes. All right. So sometimes the bottom is 100 when we're talking about grades, sometimes it isn't. It depends on whether or not the course is complete. If you are trying to calculate a grade on a course that is complete, then you will be using all of the weights, and the bottom, if you're using percentages, would be 100. If you're using decimals, it would be a 1. However, if you're talking about an incomplete course, like let's say you wanted to calculate your average right now, we haven't done the midterm or the final. That's 20% and 20% that aren't there. We haven't done the project. That's 5% that's not there. All we've done are MyMathLab, Excel, and quizzes. That's 45% in total, 10% for group discussion, and yeah, that would be it. So we've only got 55% of our grade calculated in. And it's not even a true 55% because we've barely even gotten through any homeworks, quizzes, or Excels, but you still use that 55% value for calculating your grade. All right. Do I want to do this example yet, or do I want to hold on? Yeah, we're going to hold on to this. That's going to come much later. We're going to go straight to the guided worksheets, which are here. Now, there are a lot more activities from 2.1 that we just don't have time for. By the way, right here on the screen, this should be all the answers, I believe, to the last guided activity that I assigned, the one that's due tonight. So there you go. If you weren't able to get any of those, try and go back and do the problems and see if you can achieve them. And there's still a couple of hours left on that. So you see the numbers, but remember, I don't just want the numbers, I want the work. So at least now you can verify something. More active, like I said, we don't even come close to doing all of these. If we had a whole year, I would never be able to finish all these guided activities. You'll also notice in MyMathLab, I want to point this out real quick. In the assignments, I have taken out some of the extraneous assignments in the beginning, and MyMathLab has been chugging for me this morning. Ugh, maybe I won't get to show you this. My computer reset this morning, my MathLab's being silly. I just miss being face-to-face with y'all. Come on. Okay, I'm not going to get to show it. I don't want to waste too much time, but like, it made me a liar. Okay, so y'all shouldn't even be able to, if y'all can see these, I need to get rid of them. I thought I had those not displayed. It doesn't matter. But you should only see all the stuff that you're actually doing. Oh, I know why. This isn't our course. This is the general one. Dang it. Okay, so in ours, what's happening? any of these that don't have due dates, which these were not our due dates, this 1.2 grades, you shouldn't see that anymore. I lied, I want to take the time. There we go. So you don't see the extra Excel assignments from chapter 1. I still left these review quiz and review homeworks up here. I did not create these, honestly, and they are not going to count for against your grade, but they are good review materials. Then in chapter 2, you can see that I took out all those extra Excel. So this shows you the first Excel from chapter 2 is going to be currency. The next one's going to be CPI. I haven't gotten that far in chapter 3. All I've handled so far is chapters 1 and 2. But I am going to keep doing that. So like I said, you can see all these extra Excels. I don't want you all to have to see them all semester, so I'm going to slowly be removing the ones that we don't do. And I just can't do that all at once because I do change it up each semester. And the reason I'm removing these extra things is because I had 1 or 2 students emailing me about assignments they don't have to do. Remember, pay attention to the lecture. Those are the assignments you have to do. Okay. We're scrolling. Here we go. Weighted average. So key term, weighted average, that's where you could put the formula here. Now, in the textbook, you'll see a slightly different version of this written. The textbook, it's going to look like this, that the weighted average, I use WA to abbreviate weighted average, they use this kind of weird looking E, and then they'll say weight sub K times X sub K, and then all divided by another one of those weird looking E's, and then it says weight sub K again. This right here, this weird looking E, that's known as a sigma. It's a capital sigma, it's a Greek letter. And what that says to do is add a whole bunch of things. So this symbol means add up all of them. So the top is saying add up all the different weights times their data. Is this X sub K, that's the data, the thing that we're talking about, the thing that was achieved. And the bottom says add up the weights. So this is just a more symbolic version. I will never write this again in this course. I will never put it on a homework or a test where you would be forced to use it. My personal opinion is that you should be using the version I wrote out in the text, which was just weight 1 times data 1 plus weight 2 times data 2 plus weight 3 times data 3 plus weight 4 times data 4, et cetera, all over the sum of the weights. Okay. And I'm going to have to delete all that in just a hot second so that I can scroll. The unfortunate side effect of annotating on a PDF versus Word. I wish it had the same type of annotations. But it doesn't. Okay. So here we got some updated tuition information. Looks like a little more expensive than the previous guided worksheet we were talking about, where TCEC was like $3,500 and the 4-year school was like $25,000 or something. Take a moment to think about hold on, I'm jumping the gun. The 2015-2016 tuition fees, room and board, it's also including room and board. That's what it is. In the table below are said to be enrollment weighted as indicated by the note from the National Center for Educational Statistics. Enrollment weighted. So that means if there's more students going to public 4 years, then the average should be closer to whatever their true number was. If there's a lot more students going to private 4-year schools, which we know not to be true, private schools are much lower enrollment, then the average would be much closer to that number. Or if we had the most students at 2-year schools, which off the top of my head, in the real world, I don't know which there are more of, the public 4 or the public 2, in terms of enrollment, because this changes every year. The 2-year school size is shrinking drastically, whereas the public 4 years stayed pretty stagnant with slow growth. So they say that they want to get the average. The average tuition and fees. And they came up with these numbers, 39,000, 19,000, and 9,000. So take a moment to think what this might mean if it's a weighted average. If they simply list the tuition fees and room and board for all schools and then take the arithmetic average, which would be to add them up and divide by the total, the old school average, it wouldn't take into account that there's only 2,000 students at Bowdoin, the B college, paid over $80,000, while over 30,000 students at the University of Austin or University of Tech Austin, something like that, paid 20 grand. So just averaging 20,000, 80,000 would be 50,000. If you just took 20,000 plus 80,000 and divided by 2, so 20 plus 80 is 100, 100 divided by 2 is 50. But they said there's a lot less people paying $80,000 and there's a lot more people paying the $20,000, which I think makes sense in our country. That we have a lot more people going to the cheaper schools. So again, if you were just to average those, you'd get 50,000. But if you actually consider the enrollment, the weights, how many people are actually paying 80,000, how many people are actually paying 20,000, this is what the weighted average formula would look like. So the 2,000 would be the weight, the 80,000 would be the data, the 30,000 would be the weight, the 20,000 would be the data. The weight is the thing that causes the average to shift more or less to that particular number. So 80,000 and 20,000, that's the data because that's how much the schools are costing. But if there's more students paying 80,000, if the number in front of it was bigger, then this average would come out to be closer to that number. An average cannot be more than the highest or smaller than the lowest number up there. So if you're trying to find some average between 1 and 10, it couldn't be less than 1 and it couldn't be more than 10 no matter what the weights are. So again, the weights pull it towards it. So because there's a lot more people paying 20,000, it's 30,000 of them versus 2,000 of them, the average you see is a lot closer to $20,000. If you flip this around, if there were 30,000 people paying 2 grand, I'm going to do this to the side and just say flip it, flip the weights. If there were 30,000 people paying the 80 grand plus and then we had 2,000 people paying the 20 grand, and then we divide by the sum of the weights, which is the people, the 30,000 plus the 2,000. I'll do that math in a minute. So with the original one, the 2,000 times the 80,000, 2 times 8 would be 16, and then you have 1, 2, 3, 4, 5, 6, 7 zeros. So that would be 160 million. And then the 30,000 times the 20,000 would be 60 million. I'm sorry, 600 million. And then you add the 600 million and the 16 million, and you get 760 million. The 2,000 plus the 30,000 is 32,000, and then doing that division, it comes out with 23,750. So again, because there were a lot more people paying 20,000, the average reflected that. Now, if you flip this around, if we switch the number of people paying 80 and 20, the 30,000 times the 80,000, well, 3 times 8 is 24. And there's 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So that's 2.4 billion. Plus the 2,000 times 20,000, well, 2 times 2 is 4, and there's 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7. Sorry, I'm writing kind of small, but don't have the option. So that's 40 million. And then that sum would be 244, 0, 0, 0, 0, 0, 0, 0, and then don't forget the denominator, which is the 32,000 still. See, the bottom didn't change. It was 32,000 people in the first scenario. It's still 32,000 people. It's just all we've done is swapped who's paying what. And when we do that, 6. I think I did too many zeros. You get 75,000. Actually, my cell phone calculator wouldn't even go that high. It would only let me do 240 million. It wouldn't let me do the billion, so I had to do it in my head. So again, when there were way more people paying the 80 grand, that brought the average closer to 80 grand. There's no way this average could be more than 80 grand unless there are people paying more than 80 grand. Now you might say, okay, well, where did these numbers, these numbers were accounting for all the different schools, not just 2 schools. So that's why we're not actually going to go through and calculate those. It's just giving you an example of how it was calculated. Okay, so I got to clear my screen. So again, here is your formula: weight times data plus weight times data plus weight times data, and then divide by the sum of the weights. The one difficulty, the only difficulty besides being able to put the numbers into the formula appropriately, which you need to practice doing, is figuring out which thing is the weight and which thing is the data. The weight is the thing that has an effect on typically a price or a grade value. So weight is generally something like a number of tickets or what the grade is worth. So it's very common. I'm going to put this in the Word file, which means you should be writing it down. You should always write down everything I do, but the weight is typically what a grade is worth, not the grade itself, or the number of things being purchased, or number of people doing the purchasing. So like in that tuition problem, it was the number of people paying the 80,000 to the 20,000. When we talk about doing our weighted average for our grade in class, if my math lab homework's 15%, that's the weight. If the project's worth 5%, that's the weight. The grade that you get would be the data. This is very important, understanding what the weight is, because the top, you can say, oh, it doesn't matter which thing is which because I'm just going to be multiplying and adding them. The order of multiplications don't matter. And that is true. But in the bottom, if you add the data instead of the weights, everything's going to be messed up. So what I'm going to do is I'm going to do problem 1 wrong first. I'm going to get the weight wrong, and I'm going to show you how I might be able to tell that this is wrong. Okay, so what is the average price per ticket? So we buy 8 children's tickets at $5 a piece and 2 adult tickets at $12 a piece. So we're going to the movies. 12 bucks is a little pricey for a movie, but maybe we're in that fancy 3D theater with the glasses, or maybe we're one of those like town center theaters where it's a little pricier anyways. Doesn't matter. Maybe it's just a math problem. So we buy 8 children's tickets at $5 a piece, 2 adult tickets at $12 a piece. Now, all the children's tickets are $5, all the adult tickets are $12, but we want to know what's the average price we paid for a ticket. And it should be somewhere between 5 and 12. Because we never paid less than $5 a ticket, we never paid more than $12 a ticket, so our average should be between 5 and 12. And based on the number of tickets we're buying, that should tell us which one it should be closer to. We're buying more of the children's tickets, so I feel like the average should be closer to 5 than it should be 12. So what is the average ticket price? Now again, I'm going to be doing this wrong. So this is wrong, and then I'll erase it, and I'll do it right. Let's say that I called the number of tickets the data and the cost the weight, because there are times where a cost is the weight. I'm not saying it can, I'm not saying this can never be true. This is wrong for this problem, but sometimes the cost is the weight if there's something else that we're looking at, not necessarily a number of the thing, but maybe a cost per of something. So your weighted average. Let's see, we got to have the children's tickets paired together, so it's definitely the 8 times the 5. So we're going weight times data. We called the cost the weight, so that's 5 times 8 plus. And then we have the 12 times the 2, and then that's all over. The sum of the weights, well, I called the cost the weight, so 5 plus 12. Well, 5 times 8 is 40. 12 times 2 is 24. 5 plus 12 is 17. 40 plus 24 is going to be 66. And then 66 divided by 17 is 3.88. So what is that thing that your teacher has constantly hammered you over the head, figuratively speaking, been saying every single day of class? When you get an answer, what do we say to ourselves? Does it make sense? Again, I am sorry for my sloppy handwriting. That's what using the annotation on this does to me. It's beautiful on Word, it's not on this. Does it make sense? Does it make sense that the average cost per ticket is $3.88? No. This is impossible. How is our average less than the cheapest ticket we bought? It can't be less than the cheapest. So what that means is we have either screwed up in the calculation inside the formula somewhere, or we labeled the data and the weights backwards, which is exactly what we did wrong here. I can guarantee you I did all this math correctly. My PEMDAS is on point. So we must have the labels wrong. So when I called the number of tickets the data and the cost the weight, I have to flip-flop those. What it was really supposed to be is that the number of tickets were the weight and that the price or the cost was the data. So again, I knew I made a mistake because when I got my answer, I didn't just write it down and move on like most people want to do. I asked myself, does it make sense? And I'm not going to say that it isn't possible that you get an answer that would make sense. It is certainly possible that this answer could have been like 5.2 and you're led down the wrong rabbit hole. I mean, that can happen. It's not a perfect system, this, but usually this will show that there is a hole in your argument somewhere. All right, so let's clear our screen, and we're now going to make the number of tickets the weight. So this is going to be right now. And here's the way I like to think about this. The weight is the thing that could be changed. We can't really change the $5 a ticket. We can't really change the $12 a ticket, but we could bring more people. We could bring more kids or less kids. We could bring more or less adults, and that would change what's going to happen. So the number of tickets is the weight, and then the price or the cost is the data. So now our weighted average, and again, this is correct. We're taking the weight times the data, the weight being the 8, the data being the 5. And I'm even going to put the dollar symbol up here now, since this is going to be correct. I'm going to be very, very meticulous. Then plus, so this was the children. Now we're going to account for the adults. So we'd have the weight, which is 2, because we're buying 2 of the tickets, times the data, which is 12 bucks. And then we divide by the sum of the weights. The sum of the weights, well, we had 8 tickets and 2 tickets, so 8 plus 2. Don't go through and start trying to cross things out. Don't cross out these 8s and these 2s. None of that's happening. You need to do your order of operations. 8 times 5 is 40, plus 2 times 12 is 24. Hold on a second. I think I might have said that it was 26 last time for some reason, and I don't know why I did that, but it was still wrong. Didn't matter. And then the 8 plus 2 is 10. I just realized I made a mistake earlier. I had a 66 somewhere, and it was supposed to be a 64. So the irony is I was like, oh yeah, I know my math's good, and it wasn't. Sorry about that. And then 40 plus 24 is going to be 64 divided by 10. But even if you do 64 divided by 17, that's 3.76. It's still wrong. But this 64 divided by 10 is going to be 6.4. And these were dollars. And since we're talking dollars, we usually don't just write 6.4, we write 6.40. So that is the average cost per ticket. That's the average cost per ticket. Now, if you don't trust this, what you can do is take the average and multiply it by the number of tickets you bought, and you should come up with your total cost. And 6.4 times 10 tickets is $64, and that's exactly what you would pay. 8 times 5 is going to be your 40, 2 times 12 is going to be your 24, and you add those up and you get your 64. Everyone should know how to find the total cost on problem number 1 before doing a weighted average. That's exactly what the total cost, that's exactly what the top is, in fact, of the weighted average. It's the total cost. So what are the weights? We decided that the weights were the number of tickets. So we could make this problem more complicated and say, all right, we got 8 children's tickets at $5 a piece. We got 2 adult tickets at $12 a piece. And then we bought 5 military tickets at $9 a piece. And then we bought 7 senior citizen tickets at, I don't know, $8.25 a piece. And you could say, all right, well, what was the average ticket price for everything? Because maybe you're going with some big group and you just decide that, hey, let's give everybody the same price no matter what. So we got some kids, we got some adults, we got some seniors. We're going to find out the total. We're going to divide by the number of tickets and then just make everybody pay the exact same amount no matter what. That's not something you have to do. You just go and make everybody pay exactly what they were supposed to pay in the beginning, but it's just an argument that you could have. I like to do this when I go out with friends and we have like a coupon or something. I'm a deep saver, so you bring like 50% off, and then I share it with everybody. So that weighted average would come into play there. I'm not going to go to a restaurant. Oh no, you pay full price, and I'm going to pay $5 for my cheeseburger. Let's share the love. All right, I wish I had left just a little more room for this, but that's okay. Number 2. Your grade consists of a test worth 80% and a paper worth 20%. You get a 70 on the test and a 100 on the paper. So this is a really, really, really small class. It's just 2 grades, a test and a paper. That is definitely not quantitative reasoning where we've got like 3 different assignments every day. But this is a great starting example to build us up. So your grade, 80% is a test and 20% is a paper. Can you imagine if I made 80% of your grade a test in here? You'd probably have a heart attack. And then we have the grades for them. We got a 70 on the test and 100 on the paper. So what grade do you get in the course? And then question B is, what are the weights? It's the same question B as number 1. What are the weights? Now you can answer B before A if you absolutely know. Now we did A wrong first. I don't want to waste too much time. We're going to do this right out of the gate. And I said earlier, and I typed it out, that the weights, when you're talking about grades, is the percentage that a category is worth, not what you actually earned. So the 80% and the 20%, those are the weights. It's what the test is as a percentage, or what the paper is as a percentage. So the weights are the 80% and the 20%. I'm going ahead and answering B. It's the literal weight of your grade, not the actual grade. The grade is the data. So the grade is the data. Now, I have a hard time giving the 80% and the 20% names besides weights, you might say, oh, they're the percentages. Well, some people would call the 70 a percent. They'll say, I made a 70% on the test because it's a 70 out of 100. So that's why I have to avoid calling it the percentages. The grades, the data, and then the weights, I'm just labeling them exactly. So what grade do you get in this course? Well, your weighted average. The top is the sum product, and that's what that's called, a sum product. There's actually a built-in Excel function called sum product that you could have. You would just have one column for the weights, one column for the datas, and then you go somewhere equals sum product, and then you highlight those two columns, basically. All right, so your weighted average, weight times data. So the first weight was the 80%, and I'm going to use the percentages this time. So 80% times the grade, we made a 70 on that test, plus. Then the paper was worth 20% times, and we got 100 on the paper. We kicked butt on the paper. And then divided by the sum of the weights again being the 80% and the 20%. So divided by 80% plus 20%. So I'm going to leave everything as percents. 80% times 70, so 8 times 7 is 56. Then just tag on the 2 zeros. That looks like 5,600%, plus 2 times 1 is 2, and then just have 3 zeros. So that's 2,000% divided by 80% plus 20% is 100%. Well, 56 plus 20 is going to be 76. That's 7,600%. Divided by 100%. Now I want to remind you of something, and I'm up here in the top right corner now. A divided by A is 1. Anything divided by itself is 1. 5 divided by 5 is 1. X divided by X is 1. The same thing works with units. If you have 3 inches divided by 1 inch, the units cancel and you would just get 3 divided by 1, which is 3. That's what's happening here. These percentages cancel each other out, and then you have 7,600 divided by 100, and you get 76. So that would be the weighted average of this course. That would be our calculated average. By getting a 70 on the test and 100 on the paper, we end up with a 76 in the course. And then you ask yourself, does this make sense? Well, the test was worth a lot more than the paper, so whatever we earned on the test is what our final grade should be closer to. We got a 70 on the test, 100 on the paper. 76 is definitely closer to 70 than 100. If you were to swap those weights, and I'll leave that as an exercise for you. In fact, that will be, I'm trying to think, I might not do a guided activity this weekend. I should. Actually, I will, yeah. It'll just be just a couple of them. And what's going to happen for number 2 is I'm going to have you swap the weights and see what the average comes up to. But I'll lay that out at the end. All right, so this version was done with the percents. Please note, I really wish I didn't have to clear my screen. I'm going to do the other version up here. 2A again. I'm in the top left section now. Up here. Instead of using the percents, I said that you can use decimals for percentages as well, as long as you're consistent. You can't do percents in the top and decimals in the bottom or vice versa. It's all percents or all decimals. So this 80% is going to be 0.8 and the 20% is going to be 0.2. So now I'll go 0.8 times 70 plus 0.2 times 100 divided by 0.8 plus 0.2. Weight times grade plus weight times grade divided by weight plus weight. All right, well, 0.8 times 70, 7 times 8 is 56, but you got one decimal place, so that, I'm sorry, 70 times 8 is 560, but then the decimal knocks out the 0, so that's a 56. Plus, remember, you're allowed calculators, so while you should be capable of doing this arithmetic, there's no excuse to get this wrong. 0.2 times 100, well, 2 times 100 is 200, but then you got to account for the decimals, so that's a 20, divided by 0.8 plus 0.2 is 1. I'll write it as 1.0 for clarity, but it's just 1. 56 plus 20 is 76, and 76 divided by 1 is, well, guess what, 76. The same answer. So does it matter whether you use percentages or decimals? No, as long as you're consistent and as long as you know how to convert your percents to decimals. Me personally, I prefer using decimals because look what the bottom comes out to when a class is complete. It's a 1, which means the bottom is irrelevant. So using decimals makes this a super easy calculation if the class is finished. If the class isn't finished, it honestly doesn't matter because the bottom is not going to be a 1. It's going to be a 0.8 or a 0.55 or something like that. So let's kick this up a notch. I'm going to have to clear the screen so that I can scroll down to number 3. Now assume there are 2 exams worth 40% each and a paper worth 20% each. So this is still saying that the tests are 80%, but now they're split. And I do this in the syllabus. I call the midterm and the final 40%, which means they're 20% each. You have to pay attention to those details. You have to read carefully. So assume there are 2 exams at 40% each. So there's a test worth 40, there's another test worth 40, and then there's a paper worth 20. We get a 60 on the midterm, so the first test, and 100 on the paper. So we haven't taken the final. We've only taken one of the 2 tests. What is your grade up to this point in the course? So this is not a complete course now. So this is not complete, but that doesn't mean we can't find our average. It just means we spell correctly first. Complete. There we go. Ignore that. It just means we ignore the final exam because we haven't taken it. So we're only going to count one of the 40% and the 20%. So a 60 on the midterm, and I'm going to do this with the decimals just because it's my favorite way. So the 40%, that's going to be 0.4. The 20% would be 0.2. You've got to know how to convert your percents to decimals. The point just goes twice to the left. So that's going to be 0.4. That's the weight times the grade, which was a 60 on the midterm. So this is the first test. This is the midterm. Weight times grade plus. Then we have the paper. The paper is weighted at 20%, so 0.2 times its grade of 100. And we divide by the sum of the weights. Now we're only using the weights that we have grades for, the 0.4 and the 0.2. We don't have the final. So it's the midterm weight plus the paper weight. That sounds funny, I know. The final exam and its weight are nowhere in there. I don't do 0.4 times 0 anywhere. I don't divide by the 0.4 being added in there for the final, just the midterm. All right, so 60 times 4 would be 240, but with the decimal, that makes that a 24. 100 times 2 would be 200, but with the decimal, that makes that a 20. And then 0.4 plus 0.2 is 0.6. 24 plus 20 is 44. 44 divided by 0.6. Just for the sake of time, get my calculator, and that's going to be 73.3 bar. But I'm just going to round that to 2 decimal places of 73.33. Does that make sense? Well, we got a 60 on the midterm and 100 on the paper. The midterm is worth basically 2 papers. So yeah, it makes sense that our grade is closer to the midterm than the paper. If you made a 100 on the midterm and a 60 on the paper, your grade would probably be like a 87 something. Now again, you don't have to do the decimals. You could have done this as 40% times 60 plus 20% times 100 divided by 40% plus 20%. I'm not going to show you every step, but what you ultimately end up with is 4,400% divided by 60%. The percents would cancel, and you end up doing the same math, and you get your 73.33. B, this is where things get fun. What is the highest possible grade you can get in the class? Now, that's not saying, oh, we get 100 on the midterm, 100 on the paper, and 100 on the final. No, they're saying, what is the highest possibility of a grade with the other two grades locked in? So the other grades are locked in. I would really love it for this question if someone comes into the chat and says what we need to assume. What do we assume? So we're going to do this calculation for a completed class. So we will include the final exam now. So what do we get on the final exam so that we end up with the highest possible grade? I would love someone to come in and chat and answer this one since it's pretty quick. What would you assume you get on the final exam to make the highest possible grade you can get? If I don't hear an answer in 15 seconds, I'll spoil it. Do, 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 do. Apparently I just called my dogs down. What's the highest possible grade you can earn on any single assignment? Would you want to assume that you get a 55 on the final? Would that make your grade as high as possible? Would you want to assume that you get a 77 on the final to make your grade as high as possible? Now, we're ignoring your skill. How about 100? If you assume that you make 100 on the final, that's going to make this average as high as possible. So when they ask you how to get your average as high as possible, this is the assumption we make, that we get a 100 on it. So that final, which would be weighted at 40%, that's the assumption we make. So now our weighted average, and I'm going to do the decimal version only. Here's the midterm, the 0.4 times the 60. So that's the midterm, plus. Then the paper, the 0.2 times 100. That's the paper grade weighted at 20%, the midterm grade weighted at 40%. Plus now we want our grade to be high as possible. So we assume that that 40% final, we get a 100 on it. And then divide by the sum of the weights, which is the 40% plus the paper, which is 20%, plus the final, which is also 40%. Now we already know the first two products, that was 24 and 20. The final 0.4 times 100 is going to be 40. Divided by 0.4 plus 0.2 is 0.6 plus 0.4 is 1. 24 plus 20 is 44, plus 40 is going to be 84, and 84 divided by 1 is 84. So with the grades that we currently have, this is the highest grade we can possibly get. Now, are you going to get 100 on the final? I mean, that is unlikely. Most people don't make hundreds on final exams, especially in this course. In the, 2 years I've taught this course, I think maybe I've had, I don't know, one student get 100 on the final exam. I get a lot of students make A's and B's, but it's just really hard to get a perfect 100 in a quantitative reasoning course. I don't even know that I would get a perfect 100 on a final exam for a quantitative reasoning course if I were the one taking it. I'd probably make a simple mistake somewhere, quite honestly. If I was to say take a course I wasn't teaching, that is to say, I'd get the 100 on this one unless I just wasn't paying attention. So what can you do with this information? Well, if the highest grade you can get is an 84, because there's only one more thing to get, we know we can't get an A. And that's kind of sad, but we also at least know that we could get a B. Now, what could you do with this? Well, maybe you've put some assumed grades in. You're like, all right, well, I know what I'm capable of. I know the best grade I'm going to get in the final is like an 80 or a 90 or a 70. So instead of putting the 100 there, wrong color, in that position, you could put what you think you will get. So maybe you got an 80 on the midterm, maybe you think you can replicate that, so you assume your final is an 80. And then you can calculate what your final grade should come out to be. that is an amazing opportunity for you. All semester long, you can calculate your grade, and when there's only one thing left, when we only have the final left, you can figure out the ballpark of where your grade should be. Because the final is only worth 20%. So a student who has let's say a student has gotten 100 on everything else, and it's just like, well, I'm not going to take the final because I don't feel like I should have to. And that's okay, but guess what? I don't do exemptions because I don't think we're technically allowed to. And by think, I mean I know. But what other teachers decide to do, that's their own prerogative. I like my job. But anyway, so you decide not to take the final. Well, that 20% counts as a 0, and you could calculate that your weighted average, the highest it could be, is an 80 if you had hundreds on everything else. But if you missed a single point anywhere else and didn't take the final, that means your grade at best is a 79, and now you can't get an A or a B, which says you should take that final exam. But it also says at least you're not going to fail the class or get a D in the class if you skip the final. So maybe something crazy happens in your life and you're like, look, I just got to take this B or C, whatever it is. And again, these are not things I'm telling you to do. You should take the final exam. Don't skip 20% of your grade. That's a terrible idea. The point of this problem is more to say, hey, you can go through and do your grade calculations, make some assumptions, see what happens if you get an 80, see what happens if you get a 70, see what happens if you get a 65. All right, so I got to clear my screen. And we're going to scroll down. Scroll down just enough. So there we go. Pop on the annotate. The following shows a gradebook for a class. We had a homework category worth 20% and some individual homework grades. We got quiz grades weighted at 20%, some individuals, and then down here is the average. Down here, Excel has calculated the average for us. Remember that thing I was doing earlier? This? Wow, that looks really familiar. I didn't write that homeworks were worth 15% or quizzes were worth 15% here. I certainly could have. That's exactly what's happening here. I had a bunch of individual grades, and then down at the bottom, after some blank spaces, I used the average formula built in Excel. I didn't just put that for the ones up here. I did it for all of them, which is extremely important to what we're about to discuss. All right. So the first thing they ask is, what formula is in cell B16? Which is right here, B16. So I've got something blocking my view. Column B is the homework grades. So this right here is B16. They want to know what formula is in that. Well, the first thing with Excel for a formula is always equals. And I literally typed this out earlier, but with different cell references. Average. You do not have to go equals sum and then divide by something, and if you do it that way, it will actually cause problems. You really do need to use equals average. Don't abbreviate this, don't do equals AVG. Then you open a parentheses, and inside of the parentheses, you'll have the first element, the last element, and a colon between them. So I'm gonna write something that I'm gonna erase in a second. It's supposed to be the first one, and then the last one. It always goes first, colon, last. So before the colon is the first one, after it is the last one. So here's what I'll see people do. They'll start with, okay, the first homework grade is right here, and that is cell B3. This is correct so far. But then they'll say, oh, we only have homework grades up to here, which is B7, not B5, that's the 5th homework grade. The cell reference is B7, B7. This is wrong, this is wrong, this is wrong, this is wrong, this is wrong. Because that average is only going to include these 5, and when you go and get your 6th homework and your 7th homework and your 10th homework and your 12th homework, when you put these grades in, that formula would not update. So you don't want to just have it be the last one you see in particular at the moment. You want to account for all of the future ones. So instead of stopping at B7, we have assumed 12 homeworks in total, so we need to stop down here at B14. That is the formula that should be in that cell. So when down here, I need to undo that. Oh, I'm on annotate, that's why. Come on, let me go off of annotate. There we go. It's so frustrating, these little menus that keep popping up. So if I stop that average on this one, which is B12, if I only have the average where there are grades, I don't account for the ones in the future. Watch the average of 72.18 as I put in more numbers. So I get a 0 on this one, the average for some reason updated. Why did it go to B13? If I put in a grade here, is it updating? All right, so I have mentioned before that I have a slightly weird version of Excel. This thing is auto-updating it, and I don't know why. I've never seen that happen before. But, you know, that's how life works sometimes. It's assuming as we go. So arguably, everything that I've said earlier is you can pass over if your Excel is working this way, but I'm not going to guarantee it. The appropriate way is to go ahead and have it set up for all of them. But look, as I put in new grades, it's saying, hey, you're probably going to want the next one, so it goes to B14. And then if I put in a grade here, 68. Then it goes to B15. Excel doesn't always do that. I can't tell you when it's going to do that and when it isn't going to do that because Excel has its quirks. So just get it right on the first go around. Please and thank you. All right, so what is the student's grade in this class right now? So we're going to have to do a weighted average formula for this. And there's a couple issues out of the gate. First of all, the homework grades are in single digits, but the project grade is in double digits. So did this student earn a 7 and an 8 out of 100, or did they earn a 7 and 8 out of maybe a 10? And in fact, that's what's happening here. These homework and quiz grades are out of 10 points, not 100. Whereas the project is out of 100, the midterm and the final would be out of 100. So they have scaled these things differently. So what you have to do, first of all, is change these to a 100-point scale from a 10-point scale. And you might say, well, how do we do that? It's super easy. An 8 on a 10-point scale is an 80 on a 100-point scale. A 7.825 on a 10-point scale is a 78.25 on a 100-point scale. You're just moving each decimal right once. You're multiplying them by 10 to go from 10 to 100. So these numbers, 80 and 78.25, are what we're going to use to calculate the average. You might say, well, Mr. Beckner, why aren't you using all these individual grades? The reason is we already have the average of those. So these are the numbers, the 80 and the 78.25, that'll go on the weighted average formula. We have to do the old school average of the individual homework grades to get the homework average to then put in the weighted average. And to calculate your grade in this class, that's exactly what you have to do. So what do we have? We have the homeworks at 20%. We have the quizzes at 20%. And I need you to see this word right here. You have to pay attention. The projects are 8% each, not 8% total, 8% each. That's why there isn't an average column for the projects saying this 93 is 8% of the grade. If there was another one, then that would be 8%. If there was another one, that would be 8%. These homeworks are not 20% each, it's 20% on the average. Wording is key. So we have one project. So our weighted average should be, we're going to do the homeworks, the quizzes, and the one project. So for the homeworks, the average was an 8, but we're calling it an 80, and its weight was 20%. So we go 0.2 times the 80 that we earned for an average. So this is the homework, 20% times 80, plus the quizzes are 20%, so 0.2 times, and the average of 78.25, don't round that. Then plus, then we have the project, which was 8%, that was its weight, and the data was the 93. So plus 8% times the 93, divided by the sum of the weights, which were the 0.2 for the homework, the 0.2 for the quizzes, And why did I write 8%? Why am I being inconsistent? That was silly. Eraser. That shouldn't be 8%. I should keep writing 0.08. Not 0.8, 0.08. 8% is 0.08. So plus 0.08 in the bottom. Sorry about that. And the reason I did it is because I just glanced at my worksheet, and the teacher who completed this one did them in percents, but I like doing decimals. So I'm gonna do it my way. All right, so the 0.2 times the 8, that's gonna 80 times 2 is 160, but then the decimal makes it 16, plus 78.25 times 0.2, that's gonna be 15.65, plus the 0.08 times 93 is gonna be 7.44. Ooh, what happened there? That was weird. Divided by 0.2 plus 0.2 is 0.4, so that's 0.48 when you add the 0.08. 16 plus 15.65 plus 7.44. The top's 39.09, 39.09. The bottom is going to be 0.48. And see, this is not a complete class, so the bottom's not a 1. And then 39.09 divided by 0.48, I hope y'all are working along with me, is 81.44 when rounded to 2 decimals. 81.44. That is our current grade. Now, when you only have 2 things that you're weighing, just a homework and just a test, or just a paper and just a test, it's a little easier to tell what your grade should be closer to. When you start having 3 or 4 or 5 or 10 categories, it can be a little more difficult to tell what it should be closer to, especially when all the categories have, similar weights, 15%, 20%, 10% for group work, things like that. So this is the current grade of this student right now. And again, every single one of you could go and do this type of calculation. I suggest that you all set up an Excel spreadsheet for your homeworks, your quizzes, and your Excel homeworks so that you can get those averages as you go throughout the semester. Part C. What will be her grade if she gets 100 on the next project and a 95 on the midterm? So this is still going to be an incomplete class, but now we've got a 95 on the midterm, so this is a 95, and then we get a 100 on the next project. So there's still 3 projects we haven't done. There's still a final we haven't done. We're going to assume that we haven't done any more homeworks or quizzes because they didn't say to update that. Honestly, there were probably some more homeworks and quizzes if this was a real class, but just not for this problem. Okay, so now our weighted average. We have 2 projects now, so this 100 is also at 8%. Now we have the midterm, a 95 at 10%, so we're going to need to include those in the weighted average. This formula is going to be a little beefier. So we got 0.2 times 80, the homework hasn't changed, plus 0.2 times 78.25, the quiz hasn't changed, plus 0.08 times 93, the first project hasn't changed, plus now there's the second project, so 0.08 times 100. Plus, now we have the midterm, which is a 10% of 95. So plus 0.1, that's 10% times 95. All divided by the sum of the weights, which was the 0.2. It's just all the different decimals you see in that top number. Plus the 0.2, plus the 0.08, plus the 0.08, plus the 0.1. All right, we already know the first few, that's 16 plus 15.65 plus 7.44 plus the 0.08 times 100 is going to be 8 plus the 0.1 times 95 is going to be 9.5, and then that's all divided by, we had 0.48, that's 0.56, 0.66. So then we have the 39.09 plus the 8 plus the 9.5, which is 56.59, divided by 0.66. Ends up being 85.74. Now, I can't necessarily say that one thing is pulling this grade closer to it than anything else. But what I can say is going from example B to C, look at what our average did. It went from 81 to 85, arguably an 86 depending on your teacher. I think most teachers don't round up. Maybe they do depending on the student, depending on the effort they've put in, but it's not like this 85 versus an 86 makes a difference on your grade, your letter grade. But anyways, your grade went from an 81 to an 85. We gained about 4 points. Does that make sense? What you can say is, does it make sense that our grade went up based on what we achieved? Well, in comparison to what we had before, which was an 81, we got 100 on a project, which is higher than an 81, so that should bring the grade up. And we got a 95 on the midterm, which is higher than our old average, so that should bring the grade up. I can't say that it's going to bring it up, 2 points or 5 points or 12 points specifically, but I can at least say that the grade should be pulled up. Now, I wouldn't expect the grade to end up at like a 98 or a 99 at this point, because those weights were still just small chunks. They're not going to have a major effect. They'd have a minor effect on your average. All right. So before we move on to 2.3, I got to clear my screen. Go back off of annotate. Back to our notes, which are here. This random example I mentioned earlier. Say your weights are 50% for your homework, 25% for your midterm, 25% for your final. Currently, you have an 80 on the homework and a 78 on the midterm, so your grades were all pretty close. I see grades all over the place in this course. Some of my students, they all end up being about the same, 80, 78, 82, 79, 81. And then some students make 10s and 20s on the Excel homeworks. They'll make 90s and 100s on the My Math Lab homework, 60s and 70s on the quizzes. The grades can be all over the place because there's lots of varied assignments. But anyways, not the point. What grade must you at least make on the final to get a B average, B meaning an 80% or higher? You might see a homework problem or two on this. You might see a test problem on this, hint, wink, nudge. This is something we haven't done so far. It still involves the weighted average. And it kind of feels like when we assumed we made 100 on the final, but it's not the same. There's going to be algebra involved here. So we're going to use the weighted average formula, but we can't assume a number for the final. We have to make it a variable. And I like the letter X generally, but the letter's up to you in whatever letter you like. F for final, I don't care. So we'll have the 50% times the homework grade. We'll have the 25% times the midterm grade. We'll have the 25% times the final grade. But instead of saying this equals the weighted average, we want to set the weighted average equal to 80 to achieve the goal. So instead of just saying, all right, let's make an assumption that we make the best grade on the final, let's not assume the final grade and instead assume the absolute average. And by final grade, I meant final exam grade. That was kind of a weak statement, I know. So we're going to make the actual average equal to 80. So we're going to, instead of saying weighted average equals, we'll say 80 equals. And then we show the calculation, which is weight times grade plus weight times grade plus weight times grade, the weights being the 50, the 25, and the 25. So 0.5, this is the homework weight, times the homework grade, which is an 80, plus the 25% for the midterm is a 0.25, times we got a 78 on the midterm, plus Then the final's worth 25%, so that's another 0.25 times, now we don't know what we make on the final, we called it x. Then we divide by the sum of the weights, which were the 50%, the 25%, the 25%, but I wrote decimals, so 0.5 plus 0.25 plus 0.25. Now what we got to do is solve this for x. So this equation is 80 equals 0.5 times 80, well 5 times 80 is going to be 400, that's one decimal, so that's 40, plus 0.25 times 78 ends up being 19.5, plus, we don't know what 0.25x is, so we leave that alone, then divide it by 0.5 plus 0.25 plus 0.25 is 1. I'll write the 1.0 for now. Scroll down a little more. Oh, I'm going to run out of room. So we get 80 equals, we can add the 40 and the 19.5, which would be 59.5. But we can't add the 0.25x because it's not a like term. You have got to know your simple algebra. And 1.0 is dividing by 1. We don't need to write divided by 1. So this is just 80 equals 59.5. I don't know why I just wrote 0.2. Because I was about to write 0.25, that's why. 59.5 plus 0.25x, and then we got some algebra to do. We can subtract the 59.5 on both sides. Again, if you're rusty on your algebra, you have got to figure this stuff out. Khan Academy, Purple Math, those websites are great resources. 80 minus 59.5 would be 60.5. These will cancel. And then you have your equals 0.25x. You should know how to divide by decimals, but you got calculators, so arguably you don't have to know. And I don't like that, but it is what it is. Remember, this is math for the real world, so that's okay. And then you're just doing 60.5 divided by 0.25. And I'll pull out a calculator for that since I'm not on Annotate now. $60.5 divided by 0.25. I did something wrong somewhere. $40.25 times the 78 was the 19.5 plus the 40 is 59.5. 80 minus 59. Oh, I know what I did wrong. When I did the math in my head, I called this 60 and then subtracted an extra half. That's where this 60. 80 minus 60 is 20, so this should be 20.5. 20.5. $20.5. But see what happened? I got an answer that didn't make sense. Oh, we need to get a 242 on the final to make an 80. That does not make sense. We done goofed. How about 20.5 divided by 0.25? And we need an 82. That makes a lot more sense. So 82 is equal to x. It would not make sense that we need to earn 250 points to get a B average. That wouldn't make sense since all our other grades were Bs. It's not like we failed everything. Now, if we failed everything else, it might make more sense that we need 240 points on the final, which wouldn't even be possible. You can't get anything over 100, right? So again, that whole asking yourself, does it make sense? It saves everybody, not just you. It saves me. Because these teeny little mistakes can happen. I'm doing math in my head instead of on the calculator. And I'm trying to talk and write and think at the same time. So I made a goof and I wrote a 6 instead of a 2. I got an answer that didn't make sense, so I knew to correct it. I knew I had to go back and do something. That's what I want you to learn. Now, I will admit that one was a complete mistake. Sometimes I do mistakes like that in class intentionally, like I did earlier, in fact. And then sometimes I do it on accident, like what just happened. We all make mistakes. Nobody's perfect. But when we make mistakes, we have to have a way of telling that it was wrong. It doesn't make sense. Is that way. All right, so that is 2.2. Wow, that took a lot longer to do than normally. And we'll get into 2.3 now. This little reminder here is nothing new. This is just a simple reminder on fixing cell references. If you don't want a cell reference moving left or right, you fix its column. That's how you fix a column, put it in front of the letter. If you don't want it moving up or down, you fix its row, which goes in front of the number. If you don't want it moving at all, it goes in front of both. Again, there's literally nothing new in these 3 lines, so I'm not going to talk about that again. I just keep putting it up there because it's so important and it never goes away. Now, I will admit that this weighted average formula, we're not really going to use this again throughout the course. However, you will have a problem involving the weighted average on the midterm. You will have a problem involving a weighted average on the final. You should be, throughout the semester, calculating your own grade using this weighted average formula. So you could do 15% times your homework average, plus 15% times your Excel average, plus 15% times your quiz average, plus 10% times your, quote, group work, which initially I say everybody can assume is 100, but if you aren't doing the discussion boards, again, eventually that grade would fall. So you might have to kind of make an assumption for what that is. But I'd say for now, if you're doing the discussion boards, assume it's a 100. That's a pretty good assumption. Most people get 100s for the discussion boards. It's only the people that don't do anything that I really have to punish. But we don't have any midterms or finals yet, so no 20% or 20% for there. We don't have the projects. That 5% gets skipped. So we only have 55% that we'd be dealing with in here. How do you get your My Math homework average? Add them up, divide by the number. You can go ahead and throw those 10 points in as you want to for each individual assignment, as long as you're not going over 100. You can set up an Excel spreadsheet. I'm telling you, this right here would be an amazing thing to set up for yourself to at least go ahead and have your My Math Lab average on the fly. So, all right, the next homework I got a 89 on it. Boom, my average updates. Oh, I got my next quiz grade. I got a 82 on it. Boom, my quiz grade updates. Oh, I got my next Excel grade. I can put this in here, 95.2, whatever. And then if I had that average formula down here, it would update. If you type a number in here and your average doesn't update, that tells you that you need to fix your average. You probably don't have all the cells accounted for. Okay, 2.3. Proportionality. Now, we've already kind of discussed this section. I honestly don't like that the textbook does 2.1, then 2.2, which is something out of left field, and then 2.3. I feel like we should do the weighted average and then get into talking about proportions and proportion tables and all that stuff. So we're getting back to more of the topics from 2.1 now. And I alluded to this statement previously, but if two things are directly proportional, if they are involving ratios and proportions, that means not only does if one thing increases, the other thing should increase. More specifically, if one thing doubles, the other should double. Or if one thing triples, the other should triple. Or if one thing quadruples, then the other thing should quadruple. That's what we mean by they should be going up proportionally. So it's not like if you have 2 and 3, so 2 apples, 3 bananas, and then your apples go up to, I'm sorry, not apples. Yeah, apples. I usually do apples and oranges. Let me stick to that. 2 apples, 3 oranges. If the apples go from 2 to 4, you might say, well, the apples increased by 2, so the oranges should be increasing by 2. But no, if we say they're proportional, if the apples increased from 2 to 4, that's doubled. That means the oranges should double from 3 to 6. Please note that not all pairs of data in the real world are proportional. Just because you have a table of 2 pieces of data does not mean that one thing's going up and the other thing's going up, as one thing doubles, the other thing doubles. you would have to ask yourself if this holds true. So when you're in the real world trying to say, hey, can I use this idea of a proportional relationship to find future values or expected values or predicted values, you would have to make that analysis unless someone flat out tells you they're proportional. So generally in this course, when we give you pairs of data, they're proportional, but that doesn't have to be the case. You might have to be quantitative and reason that they are proportional. You can set up a proportion, that fraction over a fraction, to find the constant of proportionality. This number will depend on which value you solve for. And I said see the text. I don't have time to pull that up. I'm just going to give you an idea on that sooner than later. We generally denote that constant of proportionality with a K. So again, I'm just taking a pause on this part for the textbook. So you can set up a proportion to find the constant of proportionality. This number will depend on which value you solve for. So 2 apples is 3 oranges. If you're solving for apples, the K would be one thing. If you're solving for oranges, the K would be a different thing. So what the constant of proportionality does for us is, let's say we know that the number of apples is, and this is not going to go with what we had earlier, is 5 times the number of oranges. This 5 would be that constant of proportionality. But this doesn't look like fraction equal a fraction. This looks like we've cross multiplied, and then it just depends on whether you solve for apples or oranges. That's what we're referring to. So again, I'm going to show you that in just a little bit. I want to pause because I'm trying to get the main point for now. So if you were to solve for either apples or oranges and it was just a number times the other thing, that's what we call the constant of proportionality. So the number of apples would be 5 times the number of oranges, or for the exact same information, if you instead solve for oranges, the number of oranges would be, in this particular example, 1/5 times the number of apples. So now, when we solve for oranges, 1/5 is the constant of proportionality. It depends on which thing you solve for. That's what I meant here. This is only when things are directly proportional. So we call that the constant of proportionality, K. You might want to call it C for constant, K for the sound of constant, that hard K sound. At least that still works, right? But when things are directly proportional, and we have this idea that if you double one thing, the other doubles, as one thing goes up, the other goes up, that idea, you can always boil this down to y equals kx. That's what this says right here. This just says y equals kx. The number of apples would be the y, the 5 would be the k, and the number of oranges would be the x. So it doesn't have to use letters of y and x. You can use a and, I don't know, j for oranges, I suppose. You can use whatever letters you like. But it just means that the relationship between them is super, super simple. This is one of the easiest and simplest mathematical relationships. And the beauty of this is almost everything in chapter 3 and 4 is going to be based off of this extremely simple mathematical relationship. There's no quadratic formulas, there's no asymptotes, no exponentials. It's just one thing is another thing times a number. That's all it says. That is direct proportionality. Direct proportionality means that if one thing doubles, the other doubles. So we're going to start throwing extra words in with this proportional. Now, if you just say proportional, you assume it's direct. If you only say proportional, you assume it's direct. I'm going to say that one more time. If you only say proportional, you assume it's direct. It means if one thing doubles, the other doubles. But there are other types of proportionality, as you can see. you have inversely proportional, which means you would say y varies inversely with x. And that says that as one thing goes up, why is that happening? As one thing goes up, the other goes down. So direct proportional means as one thing goes up, the other thing goes up. This is like your total salary if you get a pay raise. So if you get a pay raise, if your salary rate goes up, then your salary should go up. So if you doubled the number of, if you doubled your salary rate, if you made $5 an hour and you double that to $10 an hour, your total salary should double. So your total salary would be directly proportional to your hourly salary. If you double your hourly salary, your total salary should double. Or another thing that would be directly proportional is the cost you pay at the movie theater. If you buy more tickets, you're going to pay more. If you double the number of tickets you buy, then your total cost is going to double. Inversely proportional things are not always as obvious. As one thing goes up, the other thing goes down. As one thing goes up, the other thing goes down. And you could say this the other way, as one thing goes down, the other thing goes up. Think about the number of gallons of gas you'd have to buy based on your fuel efficiency, your miles per gallon. As your miles per gallon go up, that means you have to buy less fuel. So let's say you go from a car that gets 20 miles per hour to a car that gets 40 miles per hour to a more fuel efficient car. So if you're getting more if you're getting more miles per gallon on the road, that means you've got to buy less fuel. So as your fuel consumption per gallon goes up, the number of gallons of gas you have to buy goes down. That's an inversely proportional relationship. Now, you can make a statement like that as one doubles, the other doubles. For inversely proportionals, it's specifically as one doubles, the other halves. So if you double your fuel efficiency from 20 to 40, if you're buying 10 gallons of gas originally, that means you'd only have to buy 5 gallons of gas now. We will not talk about inverse proportions nearly as much in this course, but we will talk about them lightly, mainly using this y equals k over x setup. So direct proportion means y equals kx, that's a multiplication. Inverse proportions means it's y equals k over x. Now the constant is always on the top and the other variable is always on the bottom. That's important. I cannot give you all of the other different types of proportionality because there's literally infinitely many of them. This is one more popular one. Y varies directly with the square of x. We could also do y varies directly with the square root of x. I'll write that one down. Y varies directly with the square root of x. That would be y equals k times the square root of x. The extra words just tell you the extra thing to put in there. So varying with the square of x, square the x. Varying with the square root, put a square root up there. Now again, for the sake of this course, we will focus mainly on the direct proportions. But we will still see the occasional inverse and maybe wackier proportion as well. But the main idea is that we study direct proportionality because that's the easiest one to associate with in the real world with a cell phone calculator in our back pocket. All right, so here's an example. The number of students at a college varies directly, and there's other ways to phrase this is directly proportional. Varying directly is the same thing as saying directly proportional. Varying inversely would be the same as saying is inversely proportional. It's the words direct and indirect or inverse that are the clues. To the number of courses the college offers. When a college offers 75 courses, there were 1,350 students. How many students would there be if the college offered 100 courses? So these things are directly proportional, which means if one thing increases, the other thing increases. So the courses, we're going from 75 to 100, so the courses have increased. This little up arrow is me saying they've increased. So the students should increase as well because this is a direct proportion. If I said inverse, then that means the other would go down. So this is just to help us make sense at the end. we on time? 10, 11, okay. All right, so because they say it varies directly, we're going to use this y equals kx setup. Now, you don't have to do it this way. You could use the fraction equal to a fraction to figure this out, and I'll show it that way as well. I just want to make sure you see both ways because I like multiple methods. Now, which one should we call which? I will say that for 90% of the problems we do in here, it actually doesn't matter, but there is a 10% that does matter. When it matters, the thing that varies has to be by itself. So the number of students varies, blah, blah, blah. This needs to be the y. The number of students arguably needs to be the y. So y is the number of students. And I will completely admit, for this problem, it doesn't matter which one you call x and y. When you're dealing with directly proportional, it doesn't matter which one you call x and y. When you're dealing with things involving proportional to a square or a square root, this is when it matters absolutely. So we'll call y the number of students and we'll call x the number of courses. I'm not just going straight to writing numbers here. I made labels. This is good quantitative analysis. This is how students make A's instead of C's. So what we do here is we're going to jam in the first scenario. The 70, that's a giant highlight. Let me get that a little, come on, what are you doing to me? Highlight, please. We're going to jam in the first data, the 75 courses and the 1350 students in this y equals kx. So the y was the number of students. There were 1350 students. So we go 1350 equals. K, we don't know. We're going to figure that out in a second, in a minute. The x, that was the number of courses, which was 75. Now, some people will rearrange this, some people don't. 1350 equals 75k. If you don't have to do that rearrangement, that's up to you. But you do need to know how to solve this algebraic equation. You divide both sides by 75. And again, there is no excuse to not know how to do that. That is prereq knowledge. If you don't, on your own time, you need to learn that. And if you do 1350 divided by 75, you get 18. This says, so for every one course, there are 18 students. That is what this says, with a K being 18. It's not for every one student there's 18 courses, it's for every one course there's 18 students. If you don't believe this, plug in one course. You get y equals 18 times 1, which is 18. So for one course, that would be 18 students, because that's what y represents. That is the awesomeness that is finding the constant of proportionality. It gives you that 1 to whatever relationship that I alluded to in the last class. This is the multiplier where you can go from row 2 to row 3 or column 3 to column 1. That's how we find that. So if you had done this the other way, if you had said X was the number of students and Y was the number of courses, the 1350 and the 75 would be plugged in on opposite sides. And when you solve for K, you would end up getting 1/18. And that's still fine. You're just using a different setup because you're saying for every one student, there's 1/118th of a course, which means if there were 18 students, then you'd get 18 times 1/18 and you'd get your one course. But this is just a better setup because it doesn't involve a fraction. All right, so continuing on, now that we have the K, what we can do is rewrite y equals kx as y equals 18x. This is our model. This will predict all y values given x values. Because it's for every one course, there's 18 students. It's just a multiplier. So we were curious what happens with 100 courses. How many students would there be? So now we plug in 100. So we go y equals 18 times 100, and that's a pretty easy product to do. It's 1800. And don't forget your labels, that's students. So if 75 courses gets us 1350 students, then we would expect 100 courses to get us 1800 students. That's assuming that everything is directly proportional. Is this true in the real world? On a small scale, yes. On a large scale, I don't know. Eventually, you run out of students to find to sign up for your classes. So I mentioned that we could have done this instead of using the y equals kx setup, you could have done it with the fraction setup to find the k, or just to find the other number without finding the k at all. So let's do this as an alternate approach. So that was 75 courses is 1350 students. We want to know what happens with 100 courses. So use your words, write out the fraction in words. Either go courses over students or students over courses. I saw courses first, so I'll go courses over students. So this is me telling myself where things go. So the 75 related to the 1350. So I go 75 over 1350 equals. Then the other fraction. There's no proportion table set up for this, so I don't have to do the whole three corners or numbers. It's just data paired together. The 100 courses, where does that go? Top or bottom? I think it goes in the bottom. Well, no, that's students. So the 100 courses goes in the top. We don't know that one, so we call it X. We cross multiply, and we get 75X equals 1350 times 100, which is 75X equals 135000. We then divide both sides. I don't even know how I just moved that. There we go. Divide both sides by 75. And then 13.5 with all those zeros. 135,000 divided by 75 should be 1800. And then X was in a bottom, so that makes it students. So that is correct. Now you might say, Mr. Beckner, that was so much quicker and easier. Why wouldn't you just always do it that way? Maybe you've got 10 or 20 or 100 or 1,000 different scenarios you're running through. Next thing you say is, all right, well, what happens if we offer 92 courses? What happens if we offer 79 courses? What happens if we offer 30 courses? What happens if we offer 80 million courses? We have to do this cross multiplication and algebra step every time if we do this fraction setup. Every time. So we're doing math 80, 90, 100, 1,000 times if we keep doing it this way. However, if we use this y equals kx setup, if we find out what that constant is, just the number to multiply the number of courses by, you could type that in Excel, equals 18 times the cell, apply it to all 80 or 90 or 100 or 1,000 cells, hit enter, and you're done in 15 seconds. Versus it's going to take you 15 hours or God knows even more if you have to set up every single one of these fraction equations, cross multiply and solve. This is about efficiency. Yes, this works. This is about efficiency though. Let's keep on with this problem and let's say, how can we find a k? So using the fractions, to find k. So we're still going to write out the words courses over students, but I'm going to abbreviate them with letters C and S. Well, I don't actually have to. Let's not abbreviate. So I'm still going to write courses over students. Or you can do students over courses. It's up to you. And I will show it both ways. And I don't know why I wrote a colon. That should be an equals, not a colon. Because I'm actually going to have this as part of the equation instead of just a sidebar. I'm going to write the relationship that we had together, the 75 and the 1350 in appropriate spots. So 75 and 1350 with the courses on the left one in the top, that's 75 over 1350. With the right version, it's 1350 over 75. Cross multiply these. So you'll get 1350 times the number of courses equals 75 times the number of students. Times, make sure I got a dot in there so it doesn't look like 75 students. If you cross multiply this one, you'd get 75 times the number of students equals 1350 times the number of courses. See, it doesn't matter which way you did it because it just means these are on the left for this version, they're on the right for this version. Now, solve for either, it's up to you, students or courses. I'm just going to use the left version to show you that. So we got 1350 times the number of courses equals 75 times the number of students. I'm going to solve the first time. I'm going to divide both sides by the 75. I suggest to always divide by the smaller number, but it's not an end-all be-all method. And guess what? We've already done that before. 75 into 1350 was 18, right? Yes, it is. So that says that 18, wrong color, 18 times the number of courses is equal to the number of students. Which says that the K is the 18. Or if you did it the other way, if you had your 1350 courses equals 75 times students, that's a times students. If you divide both sides instead by the 1350, and this would not be my preferred way, this on the right side would reduce to a fraction. You get the number of courses is equal to 1/18 times the number of students. So this time the K is the 1/18. The K is always a reciprocal depending of the other one if you solve for the other one. So if K is 5 one way, it's 1/5 the other way. If it's 2/3 one way, it's 3/2 the other way. Reciprocal means to flip it. It just depends on what you solve for. So it is, we only have a couple minutes of class left, so I'm going to go ahead and call it a day there. We'll probably next time go straight into some guided worksheets, and then we'll get into 2.4. So we didn't really do any of the guided worksheets in 2.3, but we did a ton of guided activity, just using the same example over and over and over. And again, if you don't believe that this works, now go back and plug 100 in for the courses. If you plug 100 courses in here, 18 times 100 is 1,800 students. Or if you plug in that 100 here, you'd have to multiply both sides by 18 to clear the fraction. You really wouldn't want to use this version because you're trying to find the number of students. It's a lot, if you're trying to find the number of students, it's a lot easier to use the one that says students equals. If I was trying to find a number of courses, I would use the one that says courses equals. But again, this was all the same problem done 3 different ways. One with the assumed format of y equals kx because we were told directly proportional. One where we said because it's directly proportional, we can set fraction equal to fraction. And then one where we only use half the data so we can find the k, and then just go from there. The last thing I do want to mention is that if it's not directly proportional, can't use the fraction equal to fraction setup. 5 exclamation marks. Setting a fraction equal to a fraction is only true if two things are directly proportional. If they're inversely proportional, you have to use y equals k over x. If they're proportional to a square, you got to use y equals kx squared. There's only one of these scenarios where you can actually go fraction equal fraction. But the good thing is, moving forward in this course, it's the one we use the most. So we'll call it a day there. I'm going to say that we have done enough to call 2.3 completed. So in the details we had earlier for the due dates and such, we are going to say 2.2 and 2.3 are due on the 11th. Then your next Excel is due on the 9th. That's the car loan. I'm going to say no discussion board this time. I'm going to leave it no discussion board due on Tuesday. Definitely going to have one due next Thursday, though. And probably a quiz as well. But if you have any questions, please email me. Please stay on top of everything. Please make sure you pay for your access code. A lot of you are getting to the point where it expired either today or yesterday, depending on when you entered it. And remember, you're not going to have access to anything in this course without that code. So if you can't pay for it, you might as well just go ahead and withdraw from the course, unfortunately. And I hate to say that, but that's the truth. Have a good one. Have a good weekend. Study hard. Stay ahead. Read 2.4 and 3.1. Go ahead and look at some of those guided activities. Maybe you'll have an understanding what we'll do next time. And take it easy. This video should be up by 30 minutes from now or so.